All right, let's get into it. Today, we are cracking open the acid-base case file. We're going to take what can feel like a super complex medical puzzle and turn it into a clear, straightforward investigation with a foolproof 8-step guide.
Look, we've all been there, right? You're staring at a patient's labs. You've got pH, CO2, bicarb, and it's just this jumble of numbers. Trying to piece that story together, it can feel pretty overwhelming. Kind of like you're trying to solve a crime with a bunch of mismatched clues. But what if I told you there's a system? A single, structured approach that just works. Every time. A method that lets you solve any acid-base problem, no matter how tricky it looks on the surface. Okay, let's really dive in.
So we're going to put on our detective hats. From here on out, those lab values, they're our clues. The patient, that's our case. And the diagnosis, well, that's us solving the mystery.
And you know, every good detective needs a playbook. This is ours. It's an 8-step method that's going to guide you from that first confusing page of data to a final confident diagnosis. So here's a quick look at the first 6 steps. We start by securing and verifying our evidence. That's steps 1 and 2. Then the real investigation begins. We calculate the anion gap, hunt for the cause, and then we check to see how the body is trying to fight back.
And here are the last 2. Now these are the more advanced moves that help us uncover if there's more than one thing going on, what we call a mixed disorder. We're going to break it all down. Let's get started with step 1.
You know, every solid case starts with solid evidence. And in our world, that means getting the right samples the right way. And there is one golden rule here that you absolutely positively cannot break.
Here it is, the big one. You must draw the blood for the arterial blood gas and the electrolyte panel at the same time. I don't mean 5 minutes apart, I mean simultaneously. This is totally non-negotiable, and it's because our main clue, the bicarbonate level, is a moving target.
Think about it. When the body gets too alkaline or it's holding on to too much CO2, bicarbonate levels go up. And when it's too acidic or blowing off too much CO2, they drop. The thing is, these shifts can happen in just a few minutes.
So the risk is huge. If your samples are out of sync, your entire interpretation could be wrong right from the get-go. You'll be chasing a ghost, and your diagnosis will be built on a shaky foundation. Step 1 is everything.
Okay, so our evidence is secured. Now for step 2, we have to verify it. Here's something you might not realize. You actually get 2 bicarbonate values from your labs. The ABG gives you a calculated value based on an equation, while the electrolyte panel gives you a directly measured value. You have to make sure they're telling the same story. And here's the magic number you need to remember. The 2 values don't have to be perfectly identical, but they have to be close. They need to be within plus or minus 2 millimoles per liter of each other. This is your internal consistency check. It's how you know your data is reliable.
And what if they don't match up? Whoa, red flag. That means something is wrong with your evidence. You got to hit the brakes and immediately suspect one of 3 things: a lab error, that timing mismatch we just talked about, or a calculation mistake. Seriously, don't move on until you figure this out.
All right. Once your evidence is clean and confirmed, you're ready to find your culprit. We're moving to the real core of the investigation now, and it all starts with step 3, calculating the single most important clue for metabolic acidosis, the anion gap.
So, what is it? Put simply, the anion gap is the tool that lets you split metabolic acidosis into 2 completely different buckets. Just by calculating it, you immediately narrow down your list of suspects and point your investigation in the right direction. It's a game changer.
Now, if you find a high anion gap, there are 4 main bad guys you have to consider. And here's a fantastic way to remember them: KLRT. That stands for ketoacidosis, lactic acidosis, renal failure, and toxins. Say it with me, KLRT. This is your high-yield, most wanted list.
So what if the anion gap is normal? Well, the case just got even more focused. Now you're looking at 2 main causes. Either the body is losing bicarbonate through the GI tract, diarrhea is the classic example, or there's a specific kidney problem called renal tubular acidosis. Okay, so we've identified our primary suspect. But any good detective knows that cases are rarely that simple, right? We have to check for accomplices, for complications. We have to ask, is there a second, hidden disorder at play here?
To figure this out, we check for compensation. See, the body is smart. It's always trying to fix the imbalance. In metabolic acidosis, for instance, The lungs try to help by breathing faster to blow off CO2. In respiratory acidosis, the kidneys work overtime to hold on to bicarbonate. If that response is weaker or even stronger than what we'd expect, that is a massive clue that a second disorder is hiding in the mix.
And for our final confirmation, steps 7 and 8 give us these really powerful final clues. Step 7, for example, asks you to compare how much the anion gap changed with how much the bicarbonate changed. Think of it like this. For every bit of new acid that's added, the bicarbonate should drop by a similar amount. If it drops by way more or way less, that tells you a second metabolic problem is going on. It's an advanced move to make sure no stone is left unturned. And there, you have it. You now have the 8-step master key. And this isn't just a random list of steps. It's a logical, repeatable framework that lets you walk up to any acid-based case with total structure and confidence.
So let's just recap that framework real quick. Steps 1 and 2, that's all about securing and verifying your evidence. Steps 3 through 5 use that all-important anion gap to finger your primary suspect. And then step 6 checks to see if the body's response, the compensation, makes sense.
And finally, steps 7 and 8 are like your final cross-examination. They let you confirm if you're dealing with a really complex, mixed disorder. Following this process methodically every single time, that's what builds the skill. That's what takes you from confusion to total clarity.
So now that you have the master key, I'm going to leave you with a question to mull over. Out of all these clues, all these steps in our diagnostic playbook, which one do you think gets overlooked the most in a crazy, busy clinical setting? Think about it. The answer might just save you from making a tough misdiagnosis one day. Thanks for diving into this with me.